Alrighty, y'all. Today I'm going to be taking a look at question 3 for recitation 10, parts A and B. So for part A, we're finding the energy associated with charges 1 and 2. And for part A, we're ignoring charge 3. So to find the energy, I could do the integral and do all of that, but I'm just going to be lazy and skip to the part that I actually know, which is our electric potential energy. My already done integral for me is going to be Q1, Q2 over R. That's going to give us our electric potential energy. So if we just have our two charges, so -1 microcoulombs, that's going to be Ke times -1 times 10 to the -6 times our Q2, which is going to be our 2 times 10 to the -6. Again, I'm putting these into coulombs just to keep the units consistent. And that's going to be over the R, which is going to be 2 meters. That's R2. And then that's going to give us our energy between those two in this given situation. And if we just plug that in, that's our answer. So now we're going to move over to part B, which now we do have to pay attention to this third charge. So the change in the energy, we're looking for the change in energy of the new charge configuration when Q3 is placed, right? So I'm going to use my same equation from before. I'm use this one again, but this time I'm going to do it between each of the pairs of the charges, not electrons. They're not electrons, they're just charges. So, but we're looking for the change. So if we're going to do it between each pair, it's going to be between Q1 and Q2, Q2 and Q3, and Q1 and Q3, right? But we already did Q1 and Q2 over here when we did that. So that energy already exists in the system, and that wouldn't be the change in the energy. So our change in the energy is just going to be Q1 and Q3 plus our Ke Q1, Q2, sorry, and Q3. And this R, instead of just being a general R between the 2 points, is going to be our R between specifically each of these charges. So now we have an equation we can just plug into this. We're going to get our electric potential. It's going to be our Ke. Again, we said our Q1 was -1 times 10 to the -6. Our Q3 was -2 times 10 to the -6. And our distance between them, well, that's going to be this hypotenuse with one leg of 1, one leg of 1. So that's going to be 1 squared plus 1 squared, square root. It's going to be √2. That's going to be our radius here, √2. That's our first part. Then our second part, we're adding, again, Ke, and we're multiplying by Q2, which is 2 times 10 to the -6. And again, Q3, -2 times 10 to the -6, all over. And again, we have this hypotenuse here with, again, a side, one leg 1 and another leg 1. So that's going to be √2 again. √2. So this is going to give us our additional potential energy to the system. So if I just simplify this, I'm going to factor out the Ke, the charge of Q3, and that √2 just to make it look a little nicer. It's going to be Ke -2 times 10 to the -6 over √2 all times 1 times 10 to the -6 plus, that's a -1 because we have negative here, negative here. That's going to be plus our 2 times 10 to the -6. So yeah, we plug this into our calculator, and that's going to give us our answer for part B, which is that change in the energy. All right, well, thank you very much for watching. I hope this was helpful, And let me know if you have any more questions about this, or if you have any other problems that you want me to go over or explain. I will do my best to explain them because I guess Sydney explains stuff.